Okay, for this first video, we will be covering the answers for section A for assignment set 1. Okay, so let's take a look at the first question. In the first question, they give you a speed-time graph. So let's recap a bit about speed-time graph. So you would notice that there would be area and gradient. So the area under the speed-time graph would give me the distance, whereas the gradient would give me the acceleration. This you have to take note of it. So in the question, they ask you, what distance is traveled by the car in the first 20 seconds? So if you look at the first 20 seconds, you want to find distance, which is the area. So we can find the area under the graph. So if you notice, there is a triangle and there is also a rectangle. So the area would just be, or the distance, is just half times base times height plus the area of the rectangle. And this would give me 300 meters. Okay. Now in the next question, the question is about weight and they give you mass and they ask you about gravitational field strength. So in this question, you will have to quickly think about the formula involved, and that is W equals to mg, and you know that g would then be W over m. So when they ask you about which planet has the greatest gravitational acceleration, all you need to do is find the g for each one of them. So how do you find? So I'll just go through the first one. So the first one, you take 20, divide by 0.5, which will give you 40. If you do the same to the rest, you will get 10, 80, and 20. Okay, so your answer is straight away C. Now the next question, question number 3. Question number 3, once you see the word pivot or once you see something that looks like a seesaw, you think about moments. And you'd know the formula for moments is force times perpendicular distance. This is the first formula that you think of. And the next one that you think about is when it is balanced or when it is in equilibrium. You would have anti-clockwise moment equals to clockwise moment. So let's take a look at this picture. The first thing that you'll notice is that this 40 newtons is going to give me an anti-clockwise moment. So I'll write that down. And so the moment involved in this question would be anti-clockwise moment is force times distance, okay, which is perpendicular. So it will be 40 times 20. And this will give me 800 Newton centimeter. So I can leave my answer in centimeter. This is okay for this question. So I know that currently now there is an anti-clockwise moment. In order to rebalance, I would then know that I need a clockwise moment and I need a clockwise moment of 800 Newton centimeter. So let's read the answers out first. So if you have acting downwards and it will be to the right, it will be somewhere here, okay, and this would actually give me a clockwise moment. So this is clockwise moment. Similarly, if I do the same on the right, but it's acting upwards, this would give me an anti-clockwise moment, which I don't want. Same thing, 10 cm to the left and acting downwards. This is anti-clockwise and I also don't want it. And the last one, if you want to do it on your own, find out that it's a clockwise movement. So then I will calculate. So the first one, it will be 20 times 40, and this is straight away 800, which is what I want for my answer. Okay. Now let's take a look at the next one. The next one, the keyword is brakes. So brakes would mean that there is friction, and friction will give you heat or thermal energy. Okay. Now the next part they talk about, in a theme park ride, the passengers in the car are initially at rest at the top of the track. So when it's at rest, KE is 0. At the top of the track, there would be GPE. So at X, there would be only GPE, no KE. Now when it is at Y, if you notice there is still a height. So at Y, there would be GPE as well. Okay, and at Y, because it is still moving, therefore there would be KE. So it will be D. Let's move on to the next one. Again, when you look at a graph question, this is for distance. In distance, there is no such thing as area under the graph. There's only gradient. And the gradient gives me the speed. The gradient is also how steep it is, for those of you who are still not clear of it. So if you look at X, the gradient is increasing. And therefore the speed actually increases. So I can say that it is accelerating. Okay. At Y, if you notice, it's pretty much a straight line. So there is a constant gradient. Okay, straight line. So constant gradient would mean there is a constant speed. Okay, and the last one, if you notice, the distance did not change, and it is a horizontal line. So there is zero gradient, and it is zero speed. So at X, let's look at the options. At X, the car is not accelerating. This is not true if you look at the diagram. At Y, the car has uniform acceleration. This is wrong. It is uniform speed. Okay. At Z, the car has uniform speed. This is wrong because the car is at rest. Okay. Now for question number 7. Let's look at question number 7. If you look, there are two forces, and they ask you to calculate the acceleration of the block. So by now, you notice that the moment they give you the mass, and they give you the forces, and they ask you for acceleration, you'd know that the formula involved would be F equals to ma. But this F, you have to notice that it's actually net force, which means that in this case, it is 30 minus 10, and the mass is 20, and you want to find the acceleration, which will give me 1 meter per second square. Alright. So the diagram shows the lorry. Oops, I forgot to put the lorry. But what is the best position for the center of gravity? This one is very clear cut. it should be as low as possible so that the lorry is more stable. Okay, very clear cut. Next one, a body moving at a speed of 30 has kinetic energy of 1800 joules. So Ke, straight away you know that is half mv squared. Alright, so I can write down Ke equals to half mv squared. So 1800 equals to half times the mass, which I want to find out, times 30 squared. So here I would get my mass to be 4 kg. Alright. Question number 10. Question number 10, if I notice, the question is asking me for distance moved by the pendulum during one period. So one period is also known as one oscillation, okay, or the time taken for one oscillation. So one oscillation, you'd know that it would be from one extreme to the other and back. This is one oscillation. So I need to notice that it has to go from one end to the other and back to its original. So the answer would straight away be D. Okay. Next question. Question 11, they talk about work done. So work done, straight away my formula is force times distance, and the distance has to be parallel to the force. So if I use 300, if I notice, it is indicated in the diagram, and therefore the parallel distance that I have to use would be the one that is parallel to the force, which I highlighted. Okay, so it's times 5. Okay. Next one. Again, you see a graph. So two things that you have to take note, area or gradient. So when they talk about acceleration of the car, it would be the gradient. So they ask you about the gradient when t equals to 30. So what is the gradient at a turning point or the maximum point? Okay, so the gradient at any turning point, whether maximum or minimum point, is 0. Okay, so in this case, at t equals to 30, acceleration is 0. Let's take a look at question number 13. Question number 13, they told you the total time is 2 hours and it makes a journey of 75 kilometers. So the 2-hour journey is then used up for breaks, traffic jam, and of course the actual travel in the car. So now they ask you what is the average speed that she must travel. So now I must know how long is the car actually moving. So I must find the time that the car is moving, which is 2 hours times half an hour times a quarter of an hour. And this is 1.25 hours. So now I can calculate the speed, which is just 75 divided by 1.25, and this is 60 km per hour. Alright. So now question number 14. Question number 14, they ask you about which object has the largest volume. So you know the formula. density equals to mass over volume, or you can write down volume is mass divided by density. So I can then calculate my volume. So my volume, it will just be, I'll just write for the first one, 0.6 divided by 200, which is 0.003. If I do the same for the rest, I'll get the answer as follows. You can try it on your own if you got this question wrong. And from here, I can see that the answer will straight away be A. Okay. The next one, question 15. Question 15 is a definition question. So you would have to know that acceleration is a vector quantity. So it is defined by another vector quantity, which is velocity rather than speed. Okay. The next one, what is the name of the property of the body that resists a change in state of rest? So you know that resist a change, it will be inertia. And inertia is dependent on mass. The next part, the next part is something that you have to read out in your textbook. So from GPE to KE, it would be generating hydroelectric energy. Okay. So for the rest, this is chemical potential. To electrical energy. For nuclear power station, it will be nuclear energy to electrical energy. Geothermal is actually from your kinetic energy to GPE, but at the end of the day you will get electrical energy. Okay, so the answer for 17 is B. Question 18. Question 18, they gave me the refractive index, which is known as N, and they give me an angle of incidence, which is 45. So you must remember in this chapter, there are a few formulas. So the first one is N equals to sine I over sine R. The next one is N equals to C over V. And the last one is N equals to 1 over sine C. So there are three formulas, but in this question, we will only use the first one. So I would use N equals to sine I over sine R. So I'll write down 1.41 is sine I, which is 45, divided by sine R. From here, I can find out that R is actually 30 degrees. So now where is that 30 degrees? So initially, what happens is that this light is supposed to pass straight through. Okay, it's supposed to pass straight through, but at the end of the day, you know that it will refract. So when it refracts, it will move down, bending towards normal, and this 30 is between the normal and the ray. So you'd know, if it did not bend, the whole thing would have been 45. So now in this question, they ask you by how many degrees does the light ray change direction? So what I'm finding is this particular small little angle here, which is 45 minus 30. Alright? We are now to question number 19. In question number 19, this question is testing you about what is angle of incidence and the idea of reflection. So in the first problem, which is angle of incidence, you must know that it is always the angle between the ray and the normal. And you know that the normal is actually 90 degrees to the surface. So the angle that we are talking about is this particular angle here, which is 50 degrees. So the angle of incidence is 50. So those of you who put A and B, please be careful next time. So now when you look at reflection, you must know that in reflection, the two angles, angles of incidence and angles of reflection, they are equal. This is due to your law of reflection. Again, angle of reflection is always the angle between the normal and the ray. So the ray is called the reflected ray. Okay. Now let's look at the last question. So the last question, again, is refractive index. And this question, there are angles involved. So as we looked at the formulas earlier, you would know that the formula involved in this particular question is n equals to sine I over sine r. Okay, so I'll calculate for each one of them to find out whether it would give me 1.52. So you must remember, in sine I over sine r, the angle at the numerator or the angle at the top is always bigger than the angle at the bottom. So in this case, my first answer for A is 1.88, which is not the answer I want. So I'll do for the other diagrams. Okay. So those of you who have not tried this question, please do try again. So now for this question for 20, I saw that, hey, for B, I got the answer already. But I'm just going to check D to see whether did I calculate wrongly or not. So I see that only B actually satisfies the refractive index of 1.52. Okay, so that sums up this particular assignment for section A. Okay, so now the answers for all the questions. Let me just write it out for you. So please look through all the questions and ensure that you know how to do everything in this paper before you try assignment 2 next week.